Hey guys, this video is going to talk about correlation coefficients. So, what is correlation really? Correlation is how does one data set affect another, and whether that effect is going together or going against. That's probably not the best explanation, and if you go, Google correlation, you probably have a better way of wording it. But practically speaking, it's very easy to see what correlation is when it comes to the numbers. So we're going to run a correlation coefficient test. Going to click Data Analysis and find Correlation. Click OK. And the input range, I'm going to select the whole thing of data. And it includes all the data sets, and I'm going to include the labels. Click on the labels in first row. And I'm going to output the data set nearby. Click OK. And now we have the table for correlation coefficients. And it's a very simple process for to do this. So it doesn't take all that much work. But here's how you read the table. Now, on top, it's data A, B, C, D, E. And on the left here, it's A, B, C, D, E. So data set A and data set A itself has a perfect correlation. I mean, it is itself, right? So if the data set A goes up, well, then data set A will also go up. So that doesn't really do anything. So as you can see here, A, B, C, D, and E have perfect correlations with itself. And I put data set B in here, and I just made a copy of the data set A to show you that going down the chart, if data set B is exactly the same as data set A, it will have a perfect positive correlation. Now, data set C, I reverse the numbers. So as data set A goes up by 1, data set C goes down by 1. So you can see here, data set A starts with 1, goes up to 2, and data set C starts with 10 and goes to 9. So in this case, data set A and C have a perfect negative correlation. So it's a -1. So as you can see here, correlation coefficients is always going to be a number between 1 and -1, right? So here, data set A and D, I've made the number so that you can see a decimal point. And here you can see that it's a positive decimal, positive 0.8, and that's a pretty good correlation. And like that tells me that these two data sets, A and D, are fairly correlated. It's pretty correlated. That 0.8 is a pretty high number. And likewise, data set A and E is very closely correlated, but it's in a negative direction. Right? So I hope you guys get that, know how to read that. So a good example of a less correlated data sets are data set D and data set E. It only has a 0.6, so it's not quite as strong of a correlation as A and E with 0.9. So 0.6, I would be like, well, it's correlated a little bit, but it's not very strong. So you might, reconsider how much of a connection there is. Now, when to use this correlation coefficient? Well, it's very useful in early stages of testing something, just to give you a good feel. Just like you do descriptive statistics, and then you might do correlation of coefficients, and you may or may not do a little bit of a histogram in between. But this is an early stage kind of thing. You can get a good feel for, well, does this data set really have anything to do with the other data set? So here you go. And if you look at the answer section, I say it right there. A and B, perfect negative and perfect positive correlation. and so on and so forth. All right, that's it for correlation. Next time, we will cover t-test single sample. All right, see you next time.